The guest speaker for this ceremony is Mr. Tan Kok Yam. Mr. Tan is Deputy Secretary of the Smart Nation and Digital Government Office in the Prime Minister's Office. He's responsible for plans to realize impactful projects for Smart Nation, to raise the quality of government IT and smart systems, grow ICT-related capabilities for the Singapore government, and engage citizens and businesses to be part of the Singapore's Smart Nation journey. Mr. Tan is also Deputy Secretary in the Strategic Group and oversees issues related to data, technology, and climate change. Prior to his current position, Mr. Tan served in a number of other ministries within the Singapore Public Service. He was Director of Manpower in the Ministry of Defense, in charge of the human resource and national service policies of the Singapore Armed Forces, and also in the Ministry of National Development and the Ministry of Education, previously dealing with public housing and higher education policies respectively. Ladies and gentlemen, Mr. Tan will now address us.
Mr. Tan, member of our NTU Board of Trustees, graduates, parents of graduates, distinguished ladies and gentlemen. It gives me great honor to be here. I must say this is the first time that I'm addressing a convocation, so I'm thankful that all of you have graduated to give me the opportunity. It is customary that during such a ceremony you find someone suitably experienced, somewhat senior, presumably sensible to address you, to give words of wisdom or give words of encouragement. I guess you've got me today. The first thing to say is that is a big congratulations. You have done admirably well. You should be justifiably proud of the fact that you have graduated in a degree, because engineering is a demanding subject. Engineering demands that you have a view of the entire system, how the individual components interact, interplay, depend on one another, and how the whole system, how the whole engineering system ticks. Engineering also demands that you do the opposite, that you look into each component, because a broken cog in a machine spoils the entire machine. And finally, engineering as a subject, as a discipline, demands that you have the wisdom to know when to look at optimizing an individual component, or taking a step back and looking at the entire system, knowing when that you have to re-engineer, rejig, rearrange the system to really achieve the most effective results. And that requires wisdom. It sometimes requires hard choices. So congratulations again for being able to come to this point, for being able to graduate in what is a very, very demanding discipline and subject. Well, the next thing that I have to say is that it is only going to get more demanding. This is because the business of engineering is fundamentally transforming. And I don't mean transformation in the terms of the technology being different. That is a given. It has changed significantly by leaps and bounds from the time I myself graduated as an electrical engineer, and it will change a few years away from now. The practices, the way coding is done, the way machine learning will advance will be very different, very, very different from what you have learned in school. I don't mean that. That is a given. What I mean is that the place of engineering in organizations, in government, in society is also fundamentally changing. Now, let me give you an example from the government's point of view. You know that we are going out in a big way to push for smart nation and digital government, but what does that mean internally, from an internal practitioner's view, from an engineer's perspective? Well, for a long time, this is what we have been doing. You have a group of people in government who does policy, who makes the key strategic decisions, and then you have a second group of people in government who takes these policies, these key decisions, and attempt to implement them. These are people in your statutory boards who have to do this job well on a daily basis. And then you have a third group of people. Usually, it could be a vendor, it could be an engineering partner, it could be an IT system, a provider, who will take the implementation and come up with an engineering and IT solution to deal with that problem. And finally, there's no fourth group of people looking at data and information, how to make use of the information collected in the process of running the system to optimize it, to make it better for citizens, to make it better for the business. Now, that used to be the way that things are done. And that was an efficient way of doing it. But in the new technology landscape, it cannot be done this way. Data, which used to be an afterthought, has to be brought all the way right up in front with the policymakers, with those people who make key decisions, because we want evidence-driven, data-driven decision-making. Engineering, creating the systems, is no longer a waterfall process where the users determine what they need, pass a bunch of contractual terms to someone who will make it happen. It has become iterative. The engineer, the policymaker, the person who will run and manage the operations sit on the same table, iterate the ideas, optimize the system to achieve what is best and what is most desirable for the user, for the business, for the citizen. And that is a process that we're undergoing. It is a fundamental shift. It is a re-engineering of government itself when it comes to dealing with digital technology and technology in general. Now, what does that mean? What does that mean for the individual engineer practicing? There's only one thing that it must mean. It means that you have to communicate well. You have to listen well, speak well, and write well. And I don't mean this in a condescending term, as in engineers cannot speak or engineers cannot write. There are jokes about that, I know. But increasingly, you'll be faced with the challenge of having to explain engineering constraints, engineering concepts, engineering considerations to groups of people who need to know these things and who, if they do not know these things, will make suboptimal decisions. You have to sit down and go through those issues with them, and in a way that bridges the difference between those interested in policy, operations, and decision-making, and the engineers who are interested in designing what is best based on the technology available. And this does not just happen in government. You have terms like fintech, medtech, legal tech. You have any term, and you put a tech behind, and it is a thing, it's happening. What it means, what it tries to encapsulate is the integration, the meshing together of engineering ideas, engineering concepts, the engineering process with the typical processes of business. And engineers have to be able to bridge that gulf. Otherwise, there is no fintech if the banker does not understand the digital and the engineering concept. There's no smart nation, there's no digital government if we are not able to explain these things well to people who make decisions, and not just that, even to society at large, to the layman. This is what smart nation and digital government requires. We have been trying to do that. We have been trying to communicate through publications like our Digital Government Blueprint, our Smart Nation Strategic National Projects to the general population, but that is not enough. What is necessary is for each and every practicing engineer to be able to do that. And it's not about writing poetry, it's not about writing prose or novels. It is about being able to go back home and explain how the iPhone works to a grandmother. It's about being able to bridge that difference between people who are not practicing, not in the craft, and people who are in the craft. And you have to do that. And once you are able to do that, people around you, organizations, government, will be able to realize the immense power of your knowledge and your skills in shifting strategy, in making decisions, in prioritizing, in innovating and creating new value for the company, for the organization, for government, for society as a whole. And it's something that is almost a duty for engineers, for technologists to increasingly be able to do that. I have gone to meetings where an engineer is trying to explain something about, say, machine learning, and somehow something doesn't go through, and instead of discussing things like how you tune the algorithm to over time so that it doesn't drift, or how you want to optimize either the precision or the recall rate, the meeting ended up talking about, AI that's going to take over our jobs, AI that's going to take over civilization and our lives, and all fascinating. But as your examiner might put it, not quite pertinent to the question that we've asked you. The important part is to be able to have practical decisions, practical discussions that affect the design and the development of systems in a way that optimizes its use, its value for citizens and for businesses. And that is what digital government is about. And we will see that challenge repeated in all sectors, whether it's finance, banking, in industry, in power sector, and so on and so forth. So that is important. The second point related to this that I want to make is that, there are these Dilbert type stories and jokes about, engineers belong to a different species and cannot quite communicate with the rest of the human race. I urge all of you to ignore that. That you will, as you go and sit in your first interviews, you will come across, of course, bosses, interviewers, colleagues who will try to put you in a box, who will say, because of your engineering training, you can't do this. You can't understand sales. You can't understand public communication. You can't understand strategy. Accept that this will happen. It just doesn't just happen to engineers alone. Accept that this will happen and prove that they are wrong. That's all there is to it. I know of a colleague, a pretty senior colleague, who was rejected from NCC Air, but who later went on to become Chief of Air Force. So really ignore your first rejections as you go to the next phase of your lives. And finally, I would like to say that I start with saying that you got to find someone suitably experienced, reasonably senior, and presumably sensible in a convocation ceremony like this. But actually, experience is important, but experience is not everything. Learning is a continuous process. You don't stop learning, and I hope that as you graduate, you don't graduate from the university of life, so to speak. That you continue to acquire new perspective, new insights on how things are done, as the world, as there's meshing between physical engineering and digital engineering, as there's meshing between policy and operational decisions, between business decisions and engineering, IT, computer, digital decisions. Continuously, you'll be challenged to come up with new perspective, new ways of looking at things. Continuously, you'll be challenged not to improve the component, but to look at the whole system and how to rejig it. And part of that system, by the way, is not a mechanical or physical system. Part of the system could well be a human system operating the engineering system. Consider cybersecurity, for example. At some point, you have all these 7 layers, X layers of security. The nth layer is always the human layer. So at some point, you have to factor in the human, and that changes your view of how to design an overall engineering system. Those are new perspectives. Those are challenges, not things that not all the current experience of today may not be enough to guide us forward. And you need new ways to think about this, new insights. You'll be challenged. You'll be challenged to develop those new insights and take them as opportunities to prove yourselves, to be valuable. And with that, I thank you, and once again, congratulations.